Okay, so I think we can start. So to make sure that people are able to answer correctly, everything is working properly for people, there is usually a test question. Just to tell you briefly how your screen should look on joinpd.com, you should see a box which describes the problem, and you should also see a box where the question would be there, and then you will see a box for answering the question. Not on the screen. When I show you a problem, it will come like that. So I'll quickly show you how some screenshots of how things will look. This is how it will look. If you're on mobile, you will have to tap on answer question. On desktop, it will just show up on the same screen. Okay, so here's a sample question. And in this screen on joinpd.com, you should see a question and a box to enter a number. Okay, on that you'll be able to enter a number. There's no need to press enter or something. You just put the number and click somewhere outside. The number will come to us, and it's just a simple question. It's not a question from the graded assignment, obviously. This is just to make sure that everybody who's participating can see the screen and understand how joinpd.com works and respond. Okay, go ahead and put in your number. Let's see, according to this group of students, which is the most popular date or most important date in February. Let's see if there's any common answer. I have a few guesses as to what might be a common answer. Let's see. I'll give it just one more minute. Then we'll launch into the first of the graded assignment questions. So those who are joining in a little late and coming to these sessions for the first time, there are two ways in which you interact. One is on WebEx, which is just a video and audio. I'm just sharing the screen here with you. You can interact by putting in answers to the questions on joinpd.com. So you go to joinpd.com, put the code QUMZRE, then you can answer the questions. Come up on joinpd.com right now. If you're on the screen and you put the correct code, you'll come to the screen. You should additionally see a box where you can enter a number, or there will be this answer question tab at the bottom, which you can tap and then enter the number. There's no submit as such. Just put in the number, you're done. Okay. Okay, so I think that's it. I think there are enough people now and enough responses have come in. So let's see. So just to see what the most. So this wide variety 1, 21, 14, 15, 11, 29. Okay, so this starting fun. That's a rare date in February. 69. Wow. I don't think there is 69 in February. Okay, quite a few people have put 14, 21 maybe. Okay. So people can imagine why 21 is very popular, right? And 14 is also popular. 14 for like obvious popular reasons. 21 because your exam's coming up on 21. That's a big date for many people. So 21 is a popular date. In this group, you can see the responses. So this is something I'll do for every question. After you put in your responses, I'll just go through and look at some popular answers and comment on how they might have come. Okay. All right, so that's good. I think there are enough people now in the call participating, so we can jump into the first question, which is from similar to one of the graded assignment questions. Okay, so a brief word on how the session is structured. So I have about 4 questions which are similar to the graded assignment, and then 2 or 3 questions which are a bit different, a bit new. I thought some ideas in this area, which is important for the whole course, I should emphasize on. So I put in a few questions of that nature also. So the first 4 questions are very similar to graded assignment. And the last 3 or so, I think 4, 5 questions similar to graded assignment. Yeah, I think so. Then the last 2 or 3 are a bit different. Okay. All right, let's jump into it. Here's the first question. This is very, very similar to, I think, one of the questions in the graded assignment. So you can go through and read it. A graph is given here. This you know how to read graphs. That's one of the most important things that skills you should have. And the blue line is the graph, and there is this unfilled circle and filled circle, right? So the filled circle is actually a point on the graph. The unfilled circle is not a point on the graph. Okay, it doesn't touch. So this is given, and then you have 4 choices. Okay, on your join PD screen, you should be able to pick. You should be able to pick one of these choices. So you understand the difference between unfilled circle marker and filled circle marker, right? So if you see just a circle with no filling inside, that's an unfilled circle marker. The filled circle marker is the one which is solid, it's filled inside, dark blue that you see here. So the filled ones are on the graph, and that's a line and that's a point on the graph. So the unfilled point is not on the graph. So to give you an example, 1, 1 is not a point on the line. 2, 1 is a point on the line. And once again, don't put the answers on the chat in WebEx. The chat in WebEx is only for questions. And for putting the answers, go to joinpd.com, enter the code on top, qumzre, and then enter the answer. Okay, so I'll give you 1 more minute so that enough people can respond. Then the 0, 0 is an unfilled circle. It's not a filled circle. Okay, 0, 0 is an unfilled circle. It looks like but you can read from the pattern, right? So 0, 0 should be an unfilled circle. So sorry, we just need to click the option. There's no submit as such. You just click the option. You're done. Okay, so it's a relatively easy question. I see quite a lot of people have put in the answers. I see more than 4/5 of the people, more than 80% of the people have responded to this question. So that's nice to see. Okay. All right. So this is about definition of a function. This question. So I'm going to stop the time for answering the question. You can go ahead and answer as long as I'm on the screen. I'll move on to the solution with a relatively simple question. This is a question which helps you identify whether a graph represents a function or not. So now a function has some conditions on its definition. So let me just show you a screen which brings out this the definition very clearly. So the most important line in this slide is this: what is a valid function? You see on the right one of the lines which says a valid function. So a function is valid if for every input there should be only one output. Okay, if it has more than one sort of, when I say input output, you imagine what it is. So it's x and f of x. For every x, there should be a single f of x. If it looks like there's ambiguity in the f of x, then it's not a valid function. So that's the most important area. And this vertical line test is really a very easy way to ascertain that. Okay, so you imagine a vertical line cutting through the graph. You start with whichever value of x, you keep sweeping it, and if at any point you see that it hits 2 points on your graph, then it cannot be representing a function. Why is that? Because at that point, the function is not properly specified, right? So it's not a valid function. Now, if you go back to our example given in the problem, you'll see it's a valid function. The vertical line test, this will pass the vertical line test. There's no vertical line which hits more than one. Okay. All right. So I see people feverishly answering the question right now. So I've given away the answer already. So you can do that. So one can go back and see how many people have put in the answer correctly. So you can see a large number has put in C, and then more people are answering. I think people are deleting their wrong choice and going to the correct choice. That's okay. So you see why it's the correct answer. Hopefully you go back and read the definition. It's about the validity of the function. And then for every x, if there's only one f of x defined from the graph, then it's a valid function. and you can use this vertical line test. The horizontal line test is used for something else, and that's going to come up in the next question. Okay, so we're going to move on to question one more, but let me just quickly see the chat if there is any question which is relevant to this discussion. Let me just see real quick. Some close bracket representing on the number line. Okay. The point is, what is the purpose of giving an unfilled circle? Okay. I think that question was answered by somebody else. Thank you. All right, so there are no questions on the chat box. So let me just move on to the next question, which is on invertibility or injectivity of functions. Okay, so here's the question. I'll let you put in your response. And it's a text response. It's not choice. There are choices, but you may have multiple things right. So if you think it's just a text. So if you think A and B are right, you put A comma B. If you think A, B, C, D all are right, you can put A comma B comma C comma D. That's what you do. Okay, so there are these functions 1 plus x, 1 plus x squared, 1 plus x cubed, 1 plus x power 4. Which of these are invertible? Okay, so that's the question. I'll give a couple of minutes for this question, maybe about 2 to 3 minutes for people to process this. The hint is given. You might want to roughly sketch it and use the horizontal line test, which is for injectivity and invertibility. So I think there's this word called reversible. I'm not at least I've not seen it be used quite often in the domain of functions. Maybe it's okay. Commonly, people say invertible. I don't know. Maybe there is a terminology which is slightly different. Okay, don't put the answers in the WebEx chat. I think I've said that quite a few times. Those of you who are not used to these sessions, to put your answers, you have to go to joinpd.com and put the code QUMZRE, okay, and then enter the answer there. That's where you enter the answer. WebEx chat is only for asking technical questions on the subject matter of the question. Yes, I mean invertible, injective, one-to-one. Yes, I mean all of that is sort of the same in this sense. I mean you can make it invertible by defining your domain carefully, right? So that's it. You read it as injective. Injectivity is an important condition, right? If it's not injective, it's not going to be invertible. So the link is on the WebEx site. You can see joinpd.com, joinpd.com, and the code is on the top, QUMZRE. Okay. So there was a question about reversible, etc. If this word invertible is confusing to you, you please use the word that was used in your class. That should be okay. There's one more person putting the answer on the WebEx chat. I don't know. People who, one more person. Don't put the answer on the WebEx chat. I think people who are on WebEx, the answer needs to go on joinpd.com and enter the code QUMZRE. Then you can answer the question there. Okay. People solving the problem, do not put the answer on the WebEx chat. On joinpd.com, you can let us know that you know of the answer. Okay, so I see quite a large fraction of people have answered. And see responses coming in are slowing down. So I think it's a good time to maybe stop the question and move on to the solution. But before that, let's see the responses. Let's see how many people have responded to it. You can see most people have put out A comma Z. Then some people have put out even answers, detailed answers. There's a person who's only put A, okay, but most people have said A and C, A and C. This person who said A, B, C, D, okay. All right, so there are some wrong answers as well. But many people have said AC correctly. There's a person who said only C, 1 plus X and 1 plus X cubed. There's a person who said only A. Okay, so there are some wrong answers. So let's go through and look at the solution that I have. And like I said, the first task is to sketch the function. Okay. Now, sketching the function is can often be quite complicated, and so today you can use a lot of online tools to simplify your sketching. And one tool that I found quite useful is this desmos.com graphing calculator. Okay, so those of you who have never seen desmos.com, this is an advertisement for it. It's a pretty useful device. It's a very good app that you can quickly put in a function and get it to plot for you. So in fact, I've used the Desmos app to plot all these functions out. That's of course in an exam you can't do it, so you should know how to plot this on your own. But the sketch just sort of tells the whole story very nicely. So what I've done here is given you one more question as part of the solution. I know I'm supposed to give you the answer, but I keep giving you more and more questions. There are 4 curves here, 4 different curves. So we had a big debate in our office as to what these colors are. There are 4 colors. Maybe some of you can identify these colors and name them very clearly, but I just went with bluish. Bluish is this sort of straight line, okay? And then orangish, which some people also said light brown for that color. That's the outermost curve that you see there. And then purple. I think everybody agreed on purple. There's unanimity there. Purple is that curve. And then there was a green. I don't know. It's sort of it's fluorescent green, leaf green. I don't know what that is. Some such green. Okay. So there are 4 colors. Somebody's saying peach. Okay. Wow. All right. So I think we should have a competition on for naming the color correctly. So let's see if somebody can. Lime. Yeah, lime sounds like a good name. Let's see. Anyway, that's not the question here. The question is not to name the color. The question is which color represents which function. Okay. Please try and answer that in the choice. I'm going to spend some time on this. I think this is sort of important. Think about how these lines could represent these functions: 1 plus x, 1 plus x squared, 1 plus x cubed, and 1 plus x power 4. Yeah, I agree. It's all okay. So you can see, the choice 1 plus x is clearly the straight line bluish. I think most people would recognize 1 plus x. It's very easy to see, right? So that's the straight line that you see there. And then what about 1 plus x squared, 1 plus x power 4, 1 plus x cubed, right? How is that going to behave? And it's a bit tricky for those who have not uh, seen these things. They'll get a little confused. Let's see how confused everybody is. There's only about 50% of the people have actually answered this question. So I'm going to wait for more people to answer. But this is sort of a critical thing for you to learn. How will these kind of simple plots look? Okay, and definitely I'll very highly recommend desmos.com if you've never used it. Oh, somebody wants a white background. I had the same thing on a white background. It just didn't. I thought it didn't look clear enough, so I went to the black one. Okay, only about 50% of the people sort of have responded. So it looks like a challenging question, right? So people are taking longer time. The previous one, most people were able to answer. But this one, people are taking a longer time. The code is seen on the top right on the WebEx screen, QUMZRE. Okay, please help each other out on the chat if somebody is asking for the code. Okay, all right. Okay. So I think this has been long enough. I think let me not spend too much time on this also. So let's see who people have got it. Quite a few people have said C, and A seems to be the closest competition. Okay. All right. I can see why A and C are confusing because see, blue is easy to identify, right? 1 plus X is easy to identify. And likewise, I would argue the purple is quite easy to identify. Okay. Why is purple easy to identify? You can see it's an 1 plus X cubed. It has that sort of X cubed behavior, right? You look at the X cubed plot and lift it up by 1, it should go off negative, right? 1 plus X cubed will go negative. None of the other guys will go negative. You can sort of guess that purple should be the 1 plus X cubed. But then how do you settle between A and C? That's the question. So for that, you have to see between orange and green, or I think peach and lime green. I don't know, whatever that is. Okay, so these two colors, which one is going to be 1 plus X squared and which one is going to be 1 plus X power 4? Okay, it's an interesting question, isn't it? So notice what's happening. Between 0 and 1, 1 plus X power 4 is below 1 plus X squared. Do you see that? You can see that peach being slightly above that. In fact, you can't quite see the purple. The purple is also above the green. Okay? If you zoom in on Desmos, you'll see it. Purple will also be above the green. The green is below. But notice what happens after 1. When X becomes greater than 1, what goes above? 1 plus X power 4 goes above 1 plus X squared. So that's the behavior that will happen, okay? When you plot the polynomials, 1 plus X power 4 will be below 1 plus X squared, and X power 4 will be below X squared from 0 to 1. And when it becomes above 1, it will overtake, okay? So one needs to watch out for that. That is how you identify. Somebody made a point about flatness of the curve. 1 plus X power 4 is more flat. Yes, that's true. The slope is slowly rising compared to 1 plus X and all that. Those are also points. Okay, so these are things to keep in mind. Later on, I have another question, sort of dwelling on this a little bit more to prove these things, etc. So that's the important hint. Okay, between 0 and 1, X power 4 is going to be below X squared. And so 1 plus X power 4 will be below 1 plus X squared. Above X greater than 1, it will be the reverse. Okay, so they'll cross. And what about X equal to 0 and X equal to 1? In both places, they are equal. Okay, so they'll intersect. So a nice set of curves. So I'll urge you to play around with desmos.com. Okay, so keep trying. It's this kind of intuition is hard to build. I know there was this notion of flatness. I think people who maybe know calculus or studied calculus will understand what that is, but others may not. Just to build up intuition, just play around with desmos.com. After a few attempts, you will get a good feel for that. Okay. So that's the first part, sketching. So once you do the sketching, most of the other things are done, right? So what do you do? You have to do the horizontal line test to find injectivity or invertibility, or what reversible was used in the class. And that is a very easy test. Once again, you have these horizontal lines and sweep them from top to bottom and see if the grass is getting hit more than once. And from the sketch, you can quickly identify which graphs for which the horizontal line fails and where the horizontal line passes. So I've shown the graph here. Once again, you can see the bluish one passes the horizontal test, the orangish one fails the horizontal test, 1 plus X squared, and then purple one passes the horizontal test, and the greenish one fails the horizontal test. Okay, so this is the solution. For some reason, there's a response here. I thought I'll ask questions, but I think we are a little bit over time, I think. So I will. Oh, correct option is C. I'm sorry. That's a typo. I think I copied from the. Oh no. Wait. I'm sorry. I think this is A and C. I'm sorry. This is the original question. Okay, this is not the sketch question that I asked you. Okay, the question that I asked in the previous slide is for the plots. For that, only C is the correct answer. This is the actual answer to this entire question. What is the proper question here? The question is this one, right? This is the question. Okay, 1 plus x and 1 plus x cubed. Both of these are uh, this is the horizontal line test. These two will pass the horizontal line test, and they end up being invertible. Okay. All right. So let me just quickly go and see if there are any questions on the chat. I thought I saw quite a few questions on the chat. Let me see if there's anything interesting that one can. You can look at what is the function, the significance of a function being onto like 1 to 1 is used to see if we have an inverse or not. Okay. 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 So generally, I mean, so these sessions, I'm not going to explain the core ideas once again to you. Okay. If there are any questions on the way the solution went, I'll be able to clarify. So don't worry about these flatness, steepness, and all that. You will learn about it later. But as of now, we are only dealing with simple functions like x squared, and all that. It's not. It's you can just try it out and see how it would happen. So, for instance, the way I would think of why x power 4 needs to be lower than x squared between 0 and 1. You can simply take 0.1, for instance. You substitute 0.1. X squared is 0.01. X power 4 is 0.0001, and clearly that is lesser. Okay. 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 So I think there are some people who say they do not understand the solution. It's I mean, I could go over it once again, maybe, but I'm not sure. I think this, so one of the confusions is on the plot. It looks like there is a flat portion, doesn't it? It looks to you like there is a flat portion, and you may think that the horizontal line will intersect that flat portion in multiple places. Are you thinking like that? That's because of the scale of the plot. Okay, the plot is scaled in that fashion. If you actually go inside, if you look at 1 plus x squared or 1 plus x cubed, anything like that, as you vary x, it will keep changing it. It will never be flat. Okay, the curve sort of looks flattish, but it's not actually flat. Okay, it's because why is that? Because it's 1 plus x squared or 1 plus x cubed or 1 plus x power 4 or something like that, right? So it's not going to be flat. Okay, so don't worry about that flatness. I mean, it's not like a horizontal line test is going to fail for any of these things. Okay, so only when you have things like 1 plus x squared, which say for instance x equals minus 2 and x equals plus 2, right? For both of those, it will give you the same answer, right? So only those kind of, so don't look so close to x. It's better to go a little far away, and then you will get a better view. I think people want me to zoom in. I think this feature doesn't quite allow it. I could maybe go to some other slide and show you. So maybe I should do that. Let me just see if I can do that. So I could do this on Desmos for you. It's not too complicated. So this is how I use that. So if you want to plot, say 1 plus x, that's it. So you get 1 plus x there. Somebody wanted a white background, right? So this is background. So it's a very nice, intuitive interface. Okay, so there you go. So this is x cubed. Maybe I can do the x power 4 also. Okay, so anybody can get an account. It's just you can use your online degree Google app if you like. So let me zoom in. So you can see when I zoom in, you can see it's not really flat in any place, right? So it looks flattish, But if you keep zooming in, you'll see at every x, it will do a different. You see that? Okay, so I'll have to really zoom in for you to see these things. So keep, one needs to keep zooming quite a bit. So that's why these plots and numbers can be quite misleading. Okay, so you have to be very careful and be aware of how this works. And then you can slowly, I mean, if you keep on zooming in, eventually you'll see a slow shift out of the flatness. You can maybe see it, I don't know. Hopefully we'll see it. You have to keep on zooming. Okay, I guess. One doesn't even see it, right? I don't know. It's maybe the response is just not going to work. It's gone to 10 power minus 9, and then I guess it's not going to zoom anymore, so it's given up on me. So you can see the straight line is so much easier to deal with, and when you keep cubing, I think the way I have to zoom the x-axis differently and the y-axis differently to really show you. I'll see if I can find a good picture for you. Okay, if I find a good picture which illustrates this, I'll show you. Okay, so one way of seeing it, like I said, is to put x equals 0.1 and then 0.11, and you'll see it'll just work. And okay.
On the YouTube, they just have a confusion on the answer. Can you just repeat the answer for the two questions?
So the main question, don't worry about the intermediate question I asked you. The main question is this. Okay, this is Q2, and for Q2, the correct answer is A and C. Okay, the function A and the function C are invertible. Okay, is that fine?
And for sketch, what is the right answer? There's discussion.
For sketch, the correct answer is C. Okay, the sketch, the correct answer is C. Okay, so I see some a lot of people are confused by this. So what we would do maybe is have one of the instructors have a session in more detail on these things. These are very basic, important things. Maybe we'll go over some of this in more detail for you over another session. Okay, so let's move on. This session is, there are several other problems to look at as well, but this is important. I mean, I would say this is an important skill for you to develop. You try a few values. I think, see, you should always try a few values, right? So when you want to plot functions, put x equals 0.1, 0.2, 0.3, 0.5. You'll see the values are different, right? It's not the same. It just sort of looks flattish. It's because I'm not able to scale the y differently. Okay? Hopefully it's clear. So let's move on to the next question. Okay, so this is the next question. I know there's lots of questions on the previous one. Maybe we'll have a separate session on a plotting schedule. We have moved on to the next question. This is Q3. This is once again similar to one of the questions in the graded assignment. This is about composing two functions. What happens when you compose two functions? How do you work with it, etc. Okay. People are continuing to ask questions on the previous one. I will see if I can take it up after all the questions are over. Okay, please hold on. So I'm going to give you 2 or 3 minutes to respond. Once again, there is a text response. You have to put all the options that are correct. Yeah, you have to include all the options there. Yeah, I think somebody was answering about vertical test and horizontal test. The vertical test is to, first of all, even determine if the graph is a function, if it's a valid function or not. If it's not a valid function, we have no business talking about inverse, etc. If it is a valid function, it passes the vertical line test. You may be interested in finding out over a particular region whether it is invertible. Now, somebody asked why that is important. So what will happen usually is somebody will give you a black box and you will observe the output of the black box, and you'll be able to control, say, the input, and then you may know the function one way, how the output comes and the input goes in, right? So, and depending on the nature of that function, you may be able to design an input which will give you a specified output, right? So both of those are important in practice, in engineering practice. You may have a function, okay, yeah, fine, you know way. If you put in an input, you know how to find the output. Given the output, you may want to know what input to give so that I will get that output, right? So that's also important. So, uh, so that's where the invertibility was. Okay, let me give up one or two more minutes for this question. About half the people have answered, and I want to give more time so people can work it out. I'll give a couple of minutes more. Please take your time and put in the answer. I want to wait for at least 75-80% of the people to answer something. Please don't answer the question, answer anything on the WebEx chat. You have to answer on, there's no annotation or something. You're not answering on WebEx. You have to go to joinpd.com and put in the code QUMZRE, and then you can respond there. In fact, I know how many people have responded and all that through that. It's a very simple interactive interface. Please go there and there'll be a text box where you can enter the choices that are correct. Okay. So composition of functions also is extremely important. I keep giving you this engineering picture of how there's always some input which gets processed to get an output. That could be one function, and then people design multiple blocks and connect them up together, right? So there's one block which does one function, and then you take another block which will do another function, and then you compose the two, as in take one's output and give it as input to the next one, right? And then you get the composition, and then so this kind of things happen quite often in practice, and you have to have the mathematical tools to deal with these kind of situations. It's simple in some sense, but very powerful and useful. Okay, so I think we can stop now. I think it's about, you can see quite a few people have responded. So the responses are slowly slowing down. So about two-thirds of the people responded. So let me just show you the response. Okay. So this person has said BCD. There's a person who said ABC. There are people who have said ABCD. All are correct. All are correct. ABC, BD, CBD, ABC, ABCD. All are correct. All are correct. All are correct. So ABCD seems to be a popular answer, and I believe that's correct. All the options I've put here are correct, but there are quite a few people who have put other answers. Okay. So let me see if I can spend some time going through each of these questions and then showing you how it works maybe. Okay, so let's go through. So this is quite important. So let's go through the solution. Okay, so I put everything in one line. Hopefully the method is clear. So the first step is you have to find f of h of x and h of f of x, right? The composition both ways. Okay. So f of x is given to you, x cubed. H of x is given to you, x plus 1. Okay. One of the ways in which I see these definitions is this input output. Okay. I see x as the input. So f is like this box, and it has an input and an output, and I give it x, it gives me f of x on the outside. Okay. So if I have f of h of x, what is that? Instead of giving x, I'm giving it h of x, right? So wherever I have x in the definition, I should replace it with h of x. Okay. So notice that's what I've done here, right? F of x is x cubed. So f of h of x, wherever you have x, you replace with h of x. So you get h of x power 3. Now what do you have here? Inside you have h of x. What is h of x? It's x plus 1. So instead of h of x, I can write x plus 1 and I will get x plus 1 power 3. Okay. So now this, after this, you have to go back to your sketching skills, or you have to use your, the basic knowledge of how these functions are, and you'll see it's injective. Okay, so x plus 1 whole power 3 and x power 3 are sort of similar. So you'll get the same behavior in some sense, except that it's shifted left by minus 1 or something. Okay. What about h of f of x? Notice what's happening here. I'm doing, the h is outside, f is inside. Okay. So instead of x in h of x, I have to put f of x. Okay, once again, remember that box with input output for the function. It will be a little bit easier to think of it. So instead of x, you put f of x, so you get f of x plus 1. Now what is f of x? X cubed. So you will get x cubed plus 1. And this we saw in the previous question, right? So we know what this is. It is definitely injective. So we are done. Okay. So these are the first two options, and you can see both are correct. The next two options are just some sort of algebraic identities. So it asked you to check whether f of h of x equals h of x times x plus 1 whole square. Okay. So you can evaluate both, right? F of h of x is x plus 1 power 3. H of x times x plus 1 whole squared is also x plus 1 power 3. So these two, even though we got them differently, right? F of h of x was obtained in a different way. H of x times x plus 1 whole square is obtained in a different way, but they have identical form. Okay, so these kind of things are called algebraic identities. Many of you know many algebraic identities. So this is one such equality. So this option is correct. Now look at the next one. Next one involves a little bit of an interesting identity. If you have not seen it before, it's a useful identity to know. Okay. H of f of x is x cubed plus 1. And the other thing that's given is x plus 1 times x squared minus x plus 1. Okay, it sort of looks different. But if you multiply it out, if you try multiplying it out, you'll get x cubed plus 1. Okay. There are various ways to convince yourself that this needs to be true. Another way to convince yourself is if you put x equals minus 1 in x cubed plus 1, what will you get? So x cubed plus 1, if you put x equals minus 1, you're going to get 0, right? So minus 1 is a root of x cubed plus 1. So definitely x plus 1 is a factor of x cubed plus 1, right? So that's how we do polynomials, isn't it? So you should be able to divide x cubed plus 1 by x plus 1. And you'll see if you do the long division, the quotient will be x squared minus x plus 1. Okay? So this is one of those popular algebraic identities. Some of you might have learned it in school if you did math. Let's see. Okay, or you can also just multiply it out. You just get it. It's not like there's no way to do it. Okay. Now there is an answer box in this slide also. Some people have already entered something. I haven't even asked you the question. So somebody wants to see the question once again. That's one of the problems in this joinpd.com. I have to go back to this slide to show you the question. Hopefully this was clear to you. Is that okay? That's the question. These are the answers. So now there is another question for this slide. Okay, what is the question for this slide? I did one factoring for x cube plus 1, right? The question to you is there a similar factoring for x power 7 plus 1? Okay, is that clear? So I wrote a factoring here for x cube plus 1. Okay, is there a similar factoring for x power 7 plus 1? If you can find the factoring, enter it in the box. Okay, you can write x power 7 plus 1 is whatever factor. This is x plus 1 times something. Can you factor like that? If you can factor, can you write that down? Let me see. It's just a quick question to see. I won't wait for too long for the answer. Once about few people have answered, let's see. Okay, so I want you to think about whether x power 7 plus 1. So use the logic that I used to show you why x cube plus 1 should factor, right? By that same logic, can you get x plus 1 as a factor of x power 7 plus 1? And if yes, what is the quotient? That's all I'm asking. Okay. All right. Let me not spend too much time on this question. Let me just see if people have responded or not. Still writing ABCD. Okay, that's the question I asked you. That's the question. There you go. The binomial expansion is not the binomial expansion. This is x power 7 plus 1. The answer, one of the answers on the top here is almost right, but there is a minus after x power 5. I'm not sure if the sequencing of the signs is correct. Let me just see. Okay. Okay. So this one here sort of looks like, yeah, this is correct. So there's no bracket around x plus 1. I guess that's the only thing that's wrong with this. It is done by binomial theorem. I don't know if binomial theorem directly works here. I would rather do it just by, yeah, you can do version of the binomial theorem, yes, of course, but this is just, put x equals, the plus, if you have plus everywhere, will that work? I'm not sure if that works, right? So you have to have alternating signs, isn't it? It cannot be plus everywhere inside in the other factor. Try dividing and see what happens, okay? All right, anyway, that was just a sort of an interesting question in case you're interested in these kind of things. Okay, so we're going to move on to the next question, and let me just quickly check the chat to see if there are any interesting. So what Radhika has put in the chat is something else. So she's put x minus 1, right? So that's not what I asked. I asked for x power 7 plus 1, okay? If somebody wants the answer. The answer is, yeah, what Aishwarya has written is correct. Okay, she's put x6, x7, x5. What she means is x power 6. So what she has written is exactly correct. Okay. So how to solve is the same thing I told you. See, x power 7 plus 1 is a polynomial. If you put x equals minus 1, you get 0. So x plus 1 is a root. And you divide x power 7 plus 1 by x plus 1, you will get a quotient, and that quotient is exactly what Aishwarya has written here. To me, that's the cleanest way to solve it. There are lots of other, fancy ways to write it down. I mean, different people will give you different ideas. They are not extendable, but this root and dividing method is a fundamental method for x power 7 plus 1. You can use the same thing in so many other situations, and it will help you. Okay? So remember that method. So anytime you want to factor a polynomial, somebody gives you an algebraic identity which looks like a factoring of polynomials, try roots. That works always. Okay, so let's move on to the next question, which is Q4. This is again similar to the question that's in your graded assignment. So this describes a function a of t, which is exponential. Okay, it has a constant a0 multiplying. Then it has got half power t by gamma, and I mean a naught is given in some initial concentration. Gamma, some parameter. I believe it's called half-life parameter. And the question tells you that a of 3000 is a naught by 2. Okay, so I don't know if t is in years, I think, yeah. So after 3000 years, it goes to a naught by 2. Okay, so it's sort of like, it's called half-life. You need to find the percentage of radium in that sample. Where did radium come from? Sorry, so we are looking at the radioactive element radium. Okay. So this is for radium. Okay. A of 3000 equals A naught by 2 for radium. And for radium, what happens after 2500 years? That's the question. Hopefully the question was clear. Okay. So this is A of T. This formula is for radium's concentration in a sample. And for T equals 3000, we know it's A naught by 2. So T, what will happen? So what will be A of T as a percentage of A naught, right? So I'm interested in A of T, A of 2500 divided by A naught in percentage. Okay, let me give a few more minutes, try working it out. Once again, do not put your answers on the WebEx chat. The answers need to go to joinpd.com and put in your responses. You can enter a number which is the percentage of A of T by A naught. I'll give some time for this problem, about 5 to 6 minutes I'll give you. So take your time and do it correctly. So once again, the answers are not entered in WebEx. You're not going to annotate or write the answers in WebEx. You have to go to joinpd.com and put in the code QUMZRE and then answer the question there. Okay. Okay, about half of the people have responded, and maybe the other people are still working. So let me give one more minute, one last minute. The responses are coming in slowly, so I don't want to stop at this time. Let me give you one more minute to work this out, and then. So there's a question on submitting answers. Go to joinpd.com, enter the code qumzre, and then simply enter the number and just click elsewhere. There's no submit button. The moment you enter, the number comes to us. So once again, the answers are entered on joinpd.com. You put in the code QUMZRE, and you can simply enter the number there. There's no need to submit or anything. You just enter the number there and maybe click elsewhere. We'll get the. Okay, so all right. So I think this is sufficient time. So let me show you the responses that people have put in. We've got 83 as one answer, 56 as another answer, 43, 41. We're beginning to see 56.123 occurring often. There's a 50, there's a 64. Again, 56.123 is a popular option. We're seeing a 43, 20, 43, 43.87. A lot of people are deleting the response after seeing the answer. Okay, so it's not an exam in that sense. We're just solving it together. If you made a mistake, you can leave it there. It's okay. And 100%. Wow, this is 100. Okay, so 56 has been a popular answer. So let me just walk you through the solution that I have. And then maybe if there are any questions, we'll discuss. Okay. So these kind of problems are important. I'll tell you why these are important. Many of the models you learn or other subjects, whatever you learn, you always want to fit some function to it. Okay. Once you get that function will be in terms of some unknown parameters. Okay. And those parameters you will find based on measurements. And then you will plug it back in, and then you will do, you can do other new calculations. So this is a very common theme across a lot of science and engineering also. And any application of mathematics is very common. You will have a form for the function. There'll be this parameter gamma, for instance, right? The gamma is a very crucial parameter in this function. I'll tell you why it's crucial. And you don't know that in some sense. But you observe that is a of 3000. You measure, I mean, it need not be 3000. It can be any other value of t. You measure one value, and you see what fraction of a naught it is. It's 0.5 a naught. And it turns out that's enough to find gamma. Okay. So one measurement, there's one parameter, usually number of parameters, number of measurements. That's how it works. One parameter you have, you can find gamma. Once you find gamma, you can find it for any other value of t. So now let me read this function. I think maybe some of you were confused by what this function was. Notice what this function is. A of t equals a naught times half, right? 1 by 2, that's 0.5, half raised to the power of t by gamma. Balaji, my audio is okay, no? Hello? Is my voice is clear? Is my voice clear? I think most people are saying it's clear. Okay. So this half, the whole thing raised to the power t by gamma. Okay. So how do you evaluate it? So suppose I give you a value for gamma, I give you a value for t. You first evaluate t by gamma, and then raise half to that power. What is the meaning of raising half to that power? You can do 1 by 2 power t by gamma. If you don't like raising half to the power, you can raise half to that power, and that's how you get a of t. Okay, that's the fraction. I mean, a naught times that is a of t. Okay, so let's go through and see how one does this calculation. So like I said, there are sort of two steps. Using the one value that's given to you, you find gamma, and then plug in that value of gamma and find what you want. You want a of 2500, right? So notice what I've done here. So A of 3000 is A naught by 2, right? It's given as A naught by 2. But from the formula for A of t, you should put t equals 3000, isn't it? So you have A naught times half raised to the power 3000 by gamma. So now this A naught is going to cancel on both sides. So you will get half power 3000 by gamma equals half. So when you say just half, what is the power? That's 1, isn't it? So half power something equals half power something else, right? On the left hand side, I have 3000 by gamma. On the right hand side, I have 1. Is that okay? So half power 3000 by gamma equals half power 1. So now what should happen for this to be true? 3000 by gamma has to be equal to 1. So that's the same as gamma equals 3000. Okay, so make sure you understood this calculation. It's not very difficult, but you have to just go through it carefully and not make any silly mistake with how powers are defined and all that. Okay. Now the second step, once you find gamma, I know the function exactly, and to find the concentration at 2500, I simply plug in 2500. Okay, so that's A of 2500, which is A naught times half power 2500 by 3000. That is 5 by 6. How do you evaluate half power 5 by 6? You have to use the calculator. All of you know how to use the calculator in TCS ion centers, right? They have a wonderfully powerful calculator. So you put in 0.5 raised to the power 5 by 6. You will get 0.56123 A naught. Is that okay? Yeah, I know calc is not wonderful, unfortunately, but we have to live with what's available for us. Okay. So 56.123 is the percentage. Okay, so I want to comment on a couple of things. Okay, the first thing to understand is, so this is an exponential function, and notice what's happening, right? It's interesting to see how it behaves at 3000. At time 3000, it is at 50%. At time 2500, it's at 56%, and so on, right? So at time 0, it was at 100%. Okay, so from 0, it took such a long time to come to 56%, and seems like it has come quite fast after that, right? So this is one of the natures of this exponential variation. Suddenly it will show you a big shift. It will go off very high or very low. Okay, so that's one of the, it's the nature of this exponential function. Okay, uh, so that's important to know. So from our side, we will ensure that the questions are more easily calculated using the TCS calculator as well in the quiz. So this is a graded assignment. Of course, you are expected to have a calculator with you. You can use your own calculator. So the quiz questions, we will ensure we do a calculator check with the TCS ion calculator as well. Okay, so hopefully this was interesting, and you should be comfortable with any other form of such a question, right? So instead of exponential, you may have a function which has a parameter and some values are given. You have to substitute, manipulate it around, find the value for the parameter using the given information, and then plug in the next time value. Then the whole function is known to you. Once the function is known to you, you can do something. So there is a question about x bar y being available in the TCS ion calculator. I've given you the answer. I think the link to the calculator is there with you. You can go take a look at it. If it's not there, rest assured, such a question will not come in your quiz. Okay, don't worry about it. Okay. Okay. So that's the end of this question. So let me just see quickly the chat to see if there are any important, interesting questions that one might answer. Yeah, somebody's talking about radium's half-life. Yes, this is about half-life. And so a lot of people had put different values. So please go through and see and try to understand what mistake you made. I think that's also very important. Okay. Oh, so okay. Some people have done 100 minus 56.123, right? So many of you have answered that question. So this A of t is what is left. Okay. So that's what is A of t. So some people have done 100 minus that and given 43. So I see why. Okay, so I was wondering where the 43 came from. It seemed like a popular answer. Some people have done 100 minus that, but that's not needed here, right? So A of t, hopefully the question defined it correctly. Yeah, the concentration is what's the concentration that's left. Okay, so maybe that part was confusing to people. So hopefully that's clear. Okay, so let's move on to the next question. So I think if you add the 43 and 56, the responses were quite high. So I think most people got it right. But I also see that about only half the people have responded to the question. Uh, maybe others can go and work it out and they will get a correct answer. Okay. All right. So let's move on to the next question. We are running out of time, so I'll have to go through the next questions a bit fast. But no, the next questions are not from exactly from the graded assignment. Okay, so this is the last one. This is from the graded assignment. The others are not similar to the graded assignment, so I'll probably go through the other questions very quickly. But let's look at this question and spend some time on it and answer. Okay, so I'll give you about 3 or 4 minutes to work this out. Okay, so I can see people are responding. I'll give one more minute and then we'll quickly discuss the solution for this. Okay, so let's look at the responses. Most people have put A as the correct answer. You can see the A, suddenly the choice is increasing now once it shown me the answer. So A is the correct answer, I believe. Quite a few people have put the others also. So basically reflecting along this y equals x, right? Reflecting the mirror along y equals x is exactly like finding the inverse, okay? So I have sort of illustrated this in this picture. So you have to, this is the important thing to remember, okay? So there are three curves in this picture. The blue one is y equals x squared plus 10 for x positive. And then green is y equals x, and then the orange or the brown or whatever that is y equals square root of x minus 10. And you can see how this curve and that curve are reflected. So how do you find it? Basically, reflection about y equals x is interchange of x y. Okay, so instead of x you put y, and then instead of y you put x. You will get x equals y squared plus 10. And you just solve for y x from that. So x equals, you will get y equals square root of x minus 10. It's sort of like the inverse. You have to find the inverse of this function uh, when you reflect upon y equals x. So that's, you can sort of see, if you put a mirror here, you will see this guy exactly at in that form. How do you find the exact equation for it? This is the method. You exchange units. Somebody is saying my colors are wrong here. Really? Make mistake. How would we approach this if the hint wouldn't be given? Okay. No, you have to think about it. So this reflection about y equals x is like that. If you reflect about something else, there will be an equivalent sort of method, and that's probably a little bit more difficult to find out. Why is it x minus 10 and why not x plus 10? So there are multiple ways to answer it. So if you look at the equation y equals x squared plus 10, like I said, the way you do it is you interchange x and y. Okay, you can put x equals y squared plus 10, right? So that's what you would do if you interchange x and y. That's what happens when you reflect about the y equals x line. Okay, so now just think of it as manipulation wise, right? So x equals y squared plus 10, y squared equals x minus 10, right? And then you take the square root. So square root of x minus 10 is the inverse of x squared plus 10. You can substitute it back, right? You'll see you'll get x only when you do that. Is that okay? Think that through. It's you can see why that is true. Somebody's asking something. What will be the equation of the complete graph square root of x minus 10? Equation as in square root of x minus 10 is the equation, right? And it will keep going on and on and on the right hand side. Below 10, it's not defined, right? It's only defined for about 10. Okay, so reflection about x equal to y has this special property. Okay, yeah, we just need to find an inverse. This reflection about x equal to y is the same thing, but negative y is not showing. So I've taken the positive square root in some sense, right? Square root of x minus 10, it has to be positive because this side is also positive, isn't it? The blue curve, only the positive part is retained, isn't it? So the square root, I should take the positive square root. Okay. Okay, so we are really running out of time. We have about 10 minutes. I had prepared a few more questions, and let me just go on to one of those questions. I think it's something we discussed before. Let me see if you remember this and answer this question. Okay, take a look at this question. There are two functions. I put instead of putting values, I've put variables there: x power m and x power n. X is a positive real number. M and n are positive integers. Okay, so we want to look at the different ranges of x and how these functions behave. Okay, and I put 5 different options there. I want you to write what are all the options that are correct. Okay, which will be bigger in and m is always bigger than n. I've taken m to be bigger than n for the first 4 choices. And how will x power m behave when compared to x power n in the range 0, 1 and in the range 1, infinity. I'll give you just one more minute, because I think most people should know this answer. We discussed it during the previous thing. I'll give you about 1 or 2 minutes to put in the answers and then show you how people responded. So we just say what are all correct. Okay, so this is like I said, something we've seen before. Let's see the responses. BCE, some people are saying BC, BC, BCE, BCE, AC, AC. No, some people think A is the correct answer. I don't know why. BCE, BCE, BCD, all of them are correct. How can everything being correct is a bit unusual in this question, isn't it? Think about it. If it's going one way, it cannot go the other way also, right? So, so don't worry about infinity. Infinity is not really included. Just think of it as large as possible. So BCE, I think I would say BCE is correct. We discussed why this is true. I've written down a formal quick way to prove it for you. If x is between 0 and 1, x squared is x plus x times x, and since x is less than 1, it has to be less than or equal to x into 1, and that's x. So multiplying by a fraction will reduce the value. So as you keep, even now we'll sort of repeat it carefully enough to show x power n is lesser. And if x is greater than 1, you can use sort of the same argument to show why this has to be true. Okay. So let me just leave it like this. This is important for you to know, and it shouldn't be. Don't worry about the including of infinity. It's not included. Okay, don't worry about it. Okay, so I have. Let me just leave you with one or maybe two of these type of questions. So here are two functions. Okay, first function is 200n, and the second function is 0.01 n squared. Okay. So these are functions you've seen before, right? The first one is a linear function. You might have seen it with f of x. I've just put it as f of n here. And I'm assuming n is a positive integer, okay? Is that all right? What are positive integers? 1, 2, 3, like that, okay? So I'm interested in sort of seeing which function is going to be larger or greater as n becomes larger and larger, okay? Is that all right? That's what I'm interested in. And you can try substituting some small values for n. N equals 1 gives you 200 for f of 1. G of 1 is 0.01. N equals 2 will give you 400 for f of n. F of 2 is 400. G of 2 is 0.04, isn't it? So you see this f of n, f of 1, f of 2, they all look much larger, okay? But I'm going to ask a different sort of question. I want to ask you, is it possible that g of n is greater than f of n? Okay. So I want you to write, if you think it's not possible, there's no such n as large as, when you keep going as large as you want, however large you go, you think that, if you think that g of n will always be lesser than f of n, you can say not possible. Okay, so that's what you say. On the other hand, if you think it's possible, I want you to try and find the smallest such n. What is the smallest value of n for which this 0.01 n squared, if it can overtake 200n, right? If it does indeed overtake 200n, at what point will it overtake? Okay. I'll give you 1 or 2 minutes. We're really out of time, so I don't want to spend too much time on this. So let's see. Now, these kind of questions are very, very, very important. I cannot emphasize this question more as you study more computing, as you study more, anything. Knowing which function will be higher and lower at different points, these kind of skill, just based on the nature of the function, you should be able to sort of have a feel for what will happen when n goes larger and larger, when n is smaller, where will it flip. All these things are important things to carry away from you. I mean, it's one thing to learn about all these definitions and functions. On the ground, when you actually look at the a real problem, you will have to make a call between these two things. You may get one box which does 200n, another box which does 0.01 n squared. As an engineer, you may have to choose between these two, and you may have to make a choice. That box might be something, maybe something of value. So you have to make a call, and this kind of intuition is very, very important. Let me see. I think I've given you enough time. Let me see if the response is about 1/3 of the people have responded. Let me see if it comes up to half of the people responding. And then I'll show you what responses people have given. Could not enter response. I mean, you go to joinpd.com, enter the code QUMZRE, and then you should see a box where you can write the answer. Okay, so let me, in the interest of time, show you the responses right away. Quite a few people, at least 1 or 2 here, have got no as the answer, not possible, not possible. And then you see this 20,001. Okay, so this 20,000, okay, 20,000, 20,001. Actually, 20,001 is the more correct answer. But quite a few people keep saying not possible, not possible. Look at that. I think 20,001, yeah, people have gotten to 20,001. 0, 0, yeah, not. Some people are still saying not possible. So you can see not possible is quite a popular answer. So let's just explore this a little bit. Okay, so I want you to explore this. This is a way to explore this. Okay, so I always do this. I use Desmos or something else or some computing tool to quickly tell me what these values are. Okay, and you start with small n. Okay, so I'm starting with small n. I'm starting 1, 2, 3, 4, 5. I see 200n is like huge compared to 0.01 n squared, right? Even for 5, look at that. This is just 0.25. 200n is like 1000. Okay, but don't stop there. Be careful. Okay, so this n squared can be very deceiving. You saw the slow way it picks up and then it overtakes, right? So it can be very deceiving. So you should try larger values. So let's try larger values. Okay, so I go to 100. I still see 2001. So look at the way this is picking up, right? So and then you go to 100, n equals 100. This goes to 20,000, and then 0.01 n squared has zoomed up to 100, right? So it seems to have that big increase somewhere here, right? So I don't know. I mean, it's as you keep looking at larger and larger values, who knows what's going to happen, right? So one way to properly do this, right, is to say, let's say 0.01 n squared is greater than 200n. Okay, so if this is going to be true, what else has to be true? Let's see if we can break it down and get to the possibility, right? So 0.01 n squared is greater than 200n. Is this possible? It's possible only if you push the 200n to this side. 0.01 n squared minus 200n is greater than 0, right? It's possible only if this is true. Now this can be factored. You pull the n out. You have n times something. Product of two numbers is positive, which means what? Each of the numbers could be positive. Of course, each could be negative, but we are not looking at negative, right? So we know n is positive. So it has to happen that 0.0n minus 200 is greater than 200. Now, is that possible? You push 200 to that side, divide by 0.01. Yes, it's possible if n is strictly greater than 20,000 and n is an integer, so smallest n is 20,001. Okay, so notice how the surprising thing is working out. So one needs to be very, very careful when you do numerics like this. Okay, if you don't know the true nature of this n and n squared, you will evaluate up to 100 and say, hey, you know what, 0.01 n squared is nowhere near 200n. I'm going to go with 200n. But in reality, your n may be of the order of 20,000, 50,000. These are not big numbers today, right? And what will happen? The 200n will be killing you, and this 0.01 n squared will be giving you much better results than depending on what you want, whether you like it higher or lower. 0.01 n squared might be much larger than 200n. Okay, so be careful. You really need to know the nature of these functions and not just go by small evaluations. Okay, very important. Okay, so we're really out of time. So maybe I'll take 15 more minutes. People who want to drop off can drop off. I apologize for that. This, I think, is the last question. It's also a very similar question. I'll give you about maybe 2 or 3 minutes. Let me see. Let me see if you can answer this question. So this is sort of similar to the previous one. Again, two different types of functions, which are very deceiving if you just evaluate it for small numbers, but maybe a surprising result is true. Let's see. Let me give you a few more minutes to play around with this and then help us in the solution. Yes, 1.1 whole power n, right? Okay, since it's 1.1, it is not 1 into 1 power n, okay? It's not a constant function. It's g of n is 1.1 whole thing raised to the power n. 1.1 is one number there. Okay, so I'll give one more minute and then I'll show you. People are only slowly now responding. I know I've gone beyond the allotted time, but it just took longer. Maybe about 5 more minutes. We'll close it. This one seems a little bit more complicated, right? At least the mechanics of it, plugging in, giving you 10 power A, 10 power A. That's the reason why I did that. Let me see. I think maybe many of you wouldn't know how to manipulate this. Let me see. Give it a shot. Uh, yeah, you have to use log. Log is definitely required. So using log, this will be a complicated thing to answer. I put 10 power A, so I'll recommend. I mean, log was not officially covered yet in this class, I think. I don't know, I'm not sure. But I'm hoping some of you know log. Yeah, no, log has not been taught yet. I know. Sorry for that. I won't spend too much time on that. It's just log will help you do it. Otherwise, it's okay. Anyway, so this is like somebody pointed out, that finding the A is strictly out of syllabus in some sense, but at least knowing the nature of these functions is very, very important. I want to drive home the point that, things may look very different, and then, but, it can be very deceiving. Okay, so let's look at the solution. Okay, so look at it for small n once again. Okay, so here is n equals 2, 3, 4, 10, and 100. Okay? I'm evaluating n power 100. All right. For n equals 2, I get 2 power 100. That's, if you actually put it into a calculator, it will tell you something into 10 power 30. Okay. So 1 followed by 30 zeros. Okay. And what is 1.1 power 2? It's 1.21. This is huge. N power 100 seems like, there's no way 1.1 power n is going to come anywhere near n power 100. And the same story sort of continues, I mean, you go all the way up to 100. N power 100 is, if did I get that right? Yeah, then, okay, I forgot a zero there. I'm sorry. I don't know why I put 10 power 200. Yeah, okay, yeah, 10 power 200 is not wrong, right? So it's 100 power 100. What is 100? 100 is 10 squared. So it is 10 power 200. Okay, so look at the number. It's 1 followed by 200 zeros. 1.1 power n, even when n is 100, is only like something like 1 followed by 4 zeros, right? So it seems very small, but surprisingly, eventually, if you use this log, and let me not go into details, eventually you can see here, for n equals 10,000, okay, something as small as 10,000, 1.1 power n is going to overtake n power 100, okay. So these are surprising facts. I mean, let me not go into, like somebody pointed out, log has not been defined in this class yet. Hopefully you'll see it later. It will help you. So the answer, as it turns out, for this question is 4. Okay. We're really out of time. Thanks a lot for participating. Let me see the chat for any quick questions or anything that I might want to talk about. The camera's on. I don't see any questions here. So it's not too many questions except log not being taught. It's okay. So if you wanted to see the last slide, so let me show you the last slide again. You need to use logarithms to be able to reasonably solve this. Otherwise, it's hard. Okay. So let me leave you with one final question on the temperature check, just to see if people enjoyed it. So if you like this session, if you'd like more sessions of this type, please drag the blue dot to the green thumbs up. And please do that on joinpd.com. Okay, that will help us.
Somebody though has a headache after the session. So
it's I mean, I don't know how to. It is tough. Like I can't. I don't know. I mean, if you're not used to this, if you haven't done these kind of things before, it will seem like a lot of it coming at you. Somebody's recommending Amritanjan Tiger Bomb. So I promise you, I mean, you keep trying, you see, these ideas they'll come to you very naturally. I mean, the functions, I mean, you saw from the beginning, x squared, x power 4, x power 3, they all look deceivingly simple, but there are small ranges of values of x where they behave differently, and then another range where they behave very differently. And, that's at least to me, it's the beauty of this, isn't it? It's just there's so much variety in these things, and how you can use them. And that's the power also. If there were not this much variety, they won't be so useful in real life, right? You need so much variety in these functions, and you need to have this comfort with that, right? So tomorrow somebody shows you a graph. Internally in your mind, you should sort of say, okay, you know what, this part looks linear, this part looks quadratic, this part maybe it's cubic, maybe this is a polynomial, maybe this is an exponential growth, maybe this is a fall, and all these things should come to you. That's the most important part of learning about functions. When you see a function, you should be able to sort of feel how it behaves. So I think unless you work on these things, unless you bear the headache in some sense. You're not going to get to that. Okay. All right.
Yeah, I think just a reminder, tomorrow evening 7:30 p.m. we have a similar session for statistics 1. And day after on Thursday at 7:30 we have a live session for computational thinking. So these 3 we'll have, and the next week we'll have it for week 9. So the current ongoing thing is for week 8. We'll have it for week 9 the coming week. Your assignment submissions are due on Friday. Please do make note of your calendar, the timelines and deadlines, so that you don't miss, okay, submitting your assignment. So just that we wanted to say. Many asking about e-library. We're working on it. We'll try to get some ebooks at least to you to access. We're working with some publishers on getting some access to books. Okay. Quiz 2 results will be announced this week or next week. We are processing the results. It should come out. Okay. Thanks all. Thanks all. See you tomorrow
Okay.
evening.
Thank
Keep
you. Thank
studying.
you, everyone.
Good
Good
night.
night. Bye.